All right, let's take a look at this problem here. And again, we're continuing with some computational limit techniques. Now, we're taking the limit of the square root of x plus 4 minus 2, that's in our numerator, divided by x. And in this case, again, we're trying to find the limit as x approaches 0, a real number value. Now, when we're finding a limit at a real number value, we are hoping for continuity. That means that if we can plug 0 in for x using direct substitution, get a real number back, we would be done. However, when we plug in 0, we get 0 over 0, and that is what is called an indeterminate form in calculus as far as limits are concerned. So, what are we going to do in order to find the true value of the limit for this problem? In this case, we will be able to do something called rationalizing, and in this case, though, we're not going to rationalize the denominator, which is most common throughout Algebra 2 and pre-calculus. We're going to rationalize the numerator. And we're going to do that by introducing something called the conjugate to this problem. And in this case, we're going to introduce the conjugate of the numerator. The numerator started off as the square root of x plus 4 minus 2. The conjugate to that is the square root of x plus 4 plus 2. Most of the time, conjugates come up when dealing with complex numbers at this point in mathematical sequence, but we're going to multiply in a format of a conjugate. Now, what that will do when we distribute our numerator together, we will get rid of the middle term. When we're multiplying two binomials together, we'll have no middle term, okay, here that is concerned, as well as we're going to get rid of our radical. So, conjugates, we've got a minus b, and we are multiplying by a plus b. Conjugates will give us a squared, which is going to be then x plus 4, minus the b squared, which is going to be minus 2 times 2, so minus 4. And we're dividing all of that by x times that quantity, x plus 4, which is inside the radical, plus 2. In other words, that conjugate of the numerator that we started with. Now, once we've done our multiplication of the conjugates in the numerator, we can see that we will have 4's cancel, and we will be left with our limit as x approaches 0 of x over x times the original conjugate of the numerator, which is the square root of x plus 4 plus 2. Now we can see we've got an x in the top and an x in the bottom. We can cancel both of those out. We are left with then 1 in the numerator, so we've got 1 divided by the square root of x plus 2 plus 2. At this point, we can use direct substitution. So at this point, we can plug that 0 in, and we will have 1 divided by, and this will be the square root of 0 plus 4. That's actually a 4 under that radical. Square root of x plus 4. Okay, so I've got 0 plus 4 in that radical plus 2, or I've got 1 divided by the square root of 4, which is 2, plus 2, which will give us an answer, finally, of 4. So our answer here for this problem is 1/4, which is, again, the limit as x approaches 0 of the square root of x plus 4 minus 2, all divided by x. We did that by rationalizing the numerator here, and we ended up with a real number value of 1/4 at the end. Okay.